Off Lecture. Learn beyond class.
Hi friends and welcome to Off Lecture, Learn Beyond Class. And this is chapter 1, Patterns in Mathematics. Now let's move to patterns in shape. Patterns are not only in numbers, that they live in shapes too. Okay? And that branch is known as geometry. Geometry. This book or the book gives 5 shape sequences, irregular polygons, each with one more side, complete graphs where each dot joins with every other dot, stacked triangles, stacked square, and the coach snowflake, where every straight line becomes a speed bump for 4 shorter lines again and again. Okay, so we will come to this slide, but what I was trying to explain is, so this is another great family of pattern, that is patterns in shape, which is known as geometry. So patterns can be in multiple dimensions, or shapes can be in multiple dimensions. Shape can be 1D, it can be 2D, or it can be 3 dimension also. And mathematicians study even more. Our scope is usually limited to 3 dimensions because we can visualize up to 3 dimensions on a sheet of paper. Imagining or drawing fourth dimension or 4 dimension figures in sheet of paper is quite difficult. So we will keep our scope to 3 dimensions. And this is known as geometry, that is the branch of maths that studies patterns in shape. And what is shape sequence? A list of shapes in order, each built from one before by a rule. Okay. So the study of pattern in numbers is number theory, and study of pattern in shapes is geometry. Okay. So we have 5 shape sequences available with us. So we have regular polygons, that is simple 1D figures, regular polygons where each shape is added with one more side. So if we start with triangle, because with 2 sides we can't create a closed polygon, a closed figure. So we start with 3 because 3 can create a closed polygon. So if we have 3, this is a triangle. Let's suppose we add one more side, so it will become a quadrilateral. And if all sides are equal, then we say it's square. And if two opposite sides are equal, then we say it's a rectangle. And normally it's a quadrilateral. If we add one more side, then it becomes pentagon, as you see here, which has 5 sides. Sorry, this is not 5 sides. This becomes hexagon. This becomes pentagon. Then with 6 sides, we get hexagons and so on. Then we have complete graphs, that is K2, K3, K4, like K2, K3, K4, K5, K6, where every dot joins with every other dot. So if we start with 2 dots, we have single join. Then if we have 3 dots, that is this one, and this one, every dot is joined by other 3 dots, other 2 dots. So this is one line, this is another line, and this is third line. Then we have K4, where every 4 dots is joined by other 3 dots. So this dot is joined with this dot is joined with this dot is joined to this. And simply we go again with 5 dots, which is K5, and then K6. And then we have stacked triangles, that is rows of small triangles, one more row each time. That is this one. We have one triangle, then again we have one more row each time. So we have now 1, 2, 3, 4 triangles, then one more row, then one triangle, 1, 2, 3, 3 triangles, and then one more row. So 1, 2, 3, 4, 5, then 5 triangles, and this will go on. So this is row of small triangles, one more row added each time. Then we have stacked squares, which is this one, a square grid of small squares growing each time. So we have one square, then we have 4 squares, then we have 9 squares, then we have 16 squares, then we have 25 squares. So this is 1 square, this is 2 square, this is 3 square, this is 4 square, and this is 5 square. And then we have coach snowflake, that is every edge is replaced by a speed bump again and again. For example, this is a simple coach snowflake. So this is a triangle. Then if we add a speed bump here, just imagine this was the original triangle previously. What we have added is we have added a new speed bump, 1, 2, and 3. So this becomes a star snowflake. Then imagine this and add a speed bump here. So we will get this, and we will get this, and we will get this. So look at all 5. What they have in common. Can you tell me? One rule applied over and over? Yes. There is a one rule that has been applied over and over, and that repetition is what makes something a sequence rather than a collection. पांचों में एक ही चीज कॉमन है, एक रूल बार बार लगाया जा रहा है, बस यही चीज उसे सीक्वेंस बनाती है. अगर रूल रिपीट नहीं हो रहा तो वो सिर्फ शेप्स का ग्रुप है, सीक्वेंस नहीं. One thing also to notice about the coach snowflake that surprises most of the people. Its area stays limited, but its boundary becomes infinitely long. What it means it areas will stay limited, but its boundaries will start increasing. You can draw it in a small page, but walking along its ends would never end. And these type of shapes are also known as fractals. These shapes are also known as fractals. ओके. जैसे सोचो जरा, एक शेप जिसे तुम एक छोटे से पेज पे बना सकते हो, पर उसके बॉर्डर पर चलना कभी खत्म ही नहीं होगा. अजीब लगता है ना, पर सच है. ऐसे शेप्स को हम फ्रैक्टल कहते हैं, और नेचर में यही बादल, पहाड़ और समुद्र के किनारे में मिलती है. ओके. Now let's move to this slide, which is shapes meets number. How we can convert every shape into numbers. So every shape sequence that we have seen or we will see further hides a number sequence. Okay. So here is a big idea of this second half. Every shape sequence has a number sequence hiding inside it. You just have to count something. The main thing is you have to just count something. You have to count something. You can count the sides of the polygon, that is 3, 4, 5, 6, 7, 8, 9, 10. You can count the corners, you can count the lines or the small pieces, and then read off the numbers. Whatever you have count, you have to just read those numbers, and that will be a number sequence as well. Okay. So if we see this diagram, here we have count the number of sides. In the regular polygons, we have counted the number of sides, that is 1, 2, 3. Here we counted 1, 2, 3, and 4. But now count the corners. What you will get? What you will get? If we count 1, 2, 3, we have 3 corners here. 1, 2, 3, and 4. We have 4 corners here. 1, 2, 3, 4, 5. We have 5 corners here. What it means? Can you tell me? The same list, exactly the same. अजीब लगता है ना, पर सोचेंगे तो साफ हो जाएगा. So why must that be? Because in a closed figure, every side ends with a corner. Every side ends with a corner. And every corner joins exactly 2 sides. They pair up 1 to 1, so the counts never differ. That is, in any closed figure, the number of sides is equals to number of corners. Okay. Now, if we go back to the previous shapes, here you can see if you count the number of lines in complete graphs, if we talk about this, if we count the number of lines in complete graph, here we have 1, here we have 3, here we have 1, 2, 3, 4, 5, and 6. Then here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 15. So what we are getting here? Triangular numbers, because every new dot joins every dot already there. Okay. Now if you count the number of squares in the stack, in this stack squares, if you count the number of squares, 1, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, then 16, then 25, then 25. So it's nothing but squares number or squares number sequence. Now, if you count the number of segments of the snowflake, it will be 3. There are 3 segments. Then here we have 12. There are 12 segments. Then 48. Sorry. Then 48. Then 119 2. That is 4 times each step. If you keep on multiplying by 4, you will get the coach snowflake number sequence. तो ये याद रखना, हर शेप के अंदर एक शेप सीक्वेंस छुपी है। तुम्हें बस कुछ गिनना है, या तो वो साइड्स हो सकती हैं, या फिर कॉर्नर्स हो सकते हैं, या फिर लाइंस हो सकती हैं, या छोटे पीसेस भी हो सकते हैं। केवल काउंट करो शेप्स की लिस्ट नंबर्स की, एंड देन लिस्ट ऑटोमेटिकली बन जाएगी। ओके, नाउ लेट्स मूव टू next part, which is my activity 1.6. Count the sides and count the lines. Count the sides and count the corners in each regular polygon and the lines in each complete graph. Which number sequence do you get? We have already done this. If you see, if we count the number of sides and corners of regular polygons, we are getting 3, 4, 5, 6, 7, 8, 9, 10. So it is simple counting numbers. This is the counting numbers that we are getting. And if we talk about complete graphs, this is 1, this is 3, this is 6, this is 10, this is 15. So this is a triangular series. This is a triangular series. Okay. So this is the answer of your activity. That is, for complete graph, we got the triangular series. And when we count the number of sides and corners of a regular polygon, we are getting exactly same number, because in every closed figure, every side ends at a corner. So the counts match. Okay.